Okay, this is U4A2, Le Chatelier's Principles. This one can be tricky. Probably going to have to watch this one a couple of times. What we're doing is seeing what happens to an equation or a chemical formula that is in equilibrium, and then we throw it out of equilibrium. So follow the bouncing ball here. I'm going to try and color coordinate a little bit if I can. We'll see if this works or not. Let's say that we have a closed system, 2a plus b gives c plus d, and we add some of the a into solution. Now I'm going to use the purple to show what we first do, and then I'm going to talk about what Le Chatelier's principles say. If we throw something out of equilibrium by putting something more into the situation, then the situation is going to try and counteract this by lowering A. How does it lower A? You might have to watch this video a couple of times. It lowers A by reacting with B, so they react together. The way a chemical reaction works is if A and B react together, they will make more C and D. So the whole question here is, what happens when we add more A into the system? Well, the A is going to react with B and use it up to make more C and D. We call this favoring the products. So we're favoring the right-hand side of the reaction. There are no real reactants and products here, but we call the right-hand side the products and the left-hand side the reactants when we have an equilibrium. We call this a shift to the right. A and B go down, C and D go up. Let's try another situation where we mess with concentration. Let's say that we take some D out of the system. So we've got a flask and we want D, so we remove it. Well, what happens? The system tries to fight this. So in Le Chatelier's processes, what happens is whatever we do to the system, it tries to counteract that. So the counteraction of taking the D out is for D to try and go back up. So if D goes up, C goes up, that means B and A are going down. Once again, these arrows are up. This is a shift to the right. Okay, how would this look on a graph? Let's say we have an equilibrium. We have some C and some D. Let's say we have more A and B than we do C and D. And we take some D out. So this is D, we've taken it out. It tries to fight by coming back towards the normal. It never makes it all the way back, but it establishes a new equilibrium. Once again, what happens to C? C does what D does. It doesn't make it back all the way up, but it makes it almost all the way up. That means that these two will drop and we'll get a new equilibrium going on. So whatever you do to the concentration, we took D out, it counteracts by going up. We add A in, it counteracts by dropping A. Whatever you do, you get some type of counteraction. Okay, making sure that we've done this right here. Here we go. Volume and pressure. This is going to be important to remember. Volume is going to be the opposite of pressure. If volume goes up, it's because pressure goes down. If pressure goes down, volume goes up. So what I do is, no matter what, I convert everything into volume. Folks, you can be asked volume or pressure, convert everything into volume. So if we say the volume goes up, the volume goes up. If we say the pressure goes up, that means the opposite happens to volume, volume goes down. Next thing, count your numbers on each side. On this side, we have 2 plus 1 is 3. On this side, we have 1 plus 1 is 2. Same thing here. 2 plus 1 is 3. 1 plus 1 is 2. Hey, the bigger the volume, we're gonna favor the side with more people in it. So over here we have 3 or more species in it. Bigger volume can hold more things. So here we go. Let's say we decrease the size of the flask. So we decrease the size of the flask. That means we have fewer on this side. We're going to favor this side. We're going to favor the right. The smaller the volume, the less things it can hold. So if we say that we decrease the size of the flask, we're going to favor the side that has fewer things in it. Now what I want to do is say we're going to lower the pressure. So in the first one, we decrease the volume. In the second one, what we're going to do is decrease the pressure. Remember what I said about pressure, convert it into volume. If we decrease the pressure, we increase the volume. Increase the volume is going to favor the side with more things in it. So convert things into volume, then look for the fact, are we decreasing the volume? Go towards where there are less things. Increase the volume, go to where there are more. Last situation with Le Chatelier's is heat. If we have an exothermic reaction, we write heat on the right. Okay? Treat heat like it's a chemical. Let's say we lower the temperature. What is the counteraction to lowering the temperature? It's increasing the temperature. So whatever we do to the system tries to do the opposite. So if we lower the temperature, it tries to raise the temperature. If it raises the temperature, we'll make more D and more C, less A and less B, shift to the right. Let's say we have an endothermic reaction. And let's say here, once again, we lower the temperature. Whatever you do the counteraction to it. So A and B are going to go up, C and D are going to go down. It's a shift to the left. The left-hand side is increasing. That means a shift to the left. Folks, I would say you have to watch this a couple of times to really understand Le Chatelier's. Also dig in and watch a couple of videos.